That's where we have our server room, which has, I don't know, somewhere in the order of 500 processors for computing, doing computational fluid dynamics, finite element analysis, and obviously all of our server storage for our 3D solid modeling and that kind of thing. It's amazing how many processors you can get in a small space these days with modern computing. Over there, this is under construction, but this is where our mission control and launch control will be. So there's imagine like two big cinema screens. That's one of them, and that's another one over there in the back. And we can either have one giant image, or we can have 4 smaller images. So this whole thing is going to get laid out, and there's going to be a glass tile floor which is illuminated from below, and these cool desks with kind of blue lights. It'll look really pretty neat. So this area is where we do all of our inspection, and it's climate controlled and particulate controlled. So because metals expand and contract at different temperatures, so we always want to make sure this room is at exactly 68 degrees for doing our precision measurement. And wherever possible, we try to design a part in 3D, to manufacture it in 3D, and then to inspect it in 3D. So we minimize the number of 2D to 3D conversions. Occasionally something's better in 2D, but mostly it's better in 3D. So here we are, temperature just went down a whole lot because we're in our precision control area. And what that machine is going to do is it's going to inspect that part down to within thousandths of an inch to verify that everything was machined as it should have been. So what we have here is, that's a mass simulator of the Falcon 1 first stage engine. That's a mass simulator of the second stage engine over there. And we have what's called a full hardware in the loop simulation of the vehicle. So from an avionics and electronic standpoint and from a steering standpoint, the flight computer and avionics think that they're flying the vehicle to space, and then we verify that they've done the computer's actually done all the things it's supposed to do to make the rocket get successfully to space. So here we're in our avionics test facility. That's where we do test avionics of all sizes and shapes. So here we have a bunch of thermal cycling chambers that'll take parts and put them through 50 thermal cycles to verify that things are going to be okay. And the temperature environment in space is much worse than on the ground because you don't have air to even out the temperature. So you could actually have something could be in searing sunlight or blackest night, and it's got to be able to handle much more of a temperature range than it would on Earth. That's a thermal vacuum cycler, so it'll test both. It'll test the out part in vacuum going through the temperature cycles. That's our shaker room. It's got two small and a big shaker, so we can simulate the enormous acoustic and vibrational loads that parts experience during the rocket takeoff. And that's really where things tend to break more than any other place.
Hey, how are you?
Good. We're just doing a little video blog thing of what's that. Yes, exactly.
I'm Elon I'm an avionics engineer. What I'm doing here right now is to set up for a test upcoming of our second stage that we're going to send out to Texas for a hot fire. What you see here is our electrical ground support equipment, a copy of what we actually have out on Quadrant on the launch pad. We do exactly a one-to-one replica here to test out the stages before we send them out. So we will be putting the stage through its paces tomorrow, and we're just doing some preparatory work right now.
Yeah, this is our electromagnetic interference test chamber. It looks vaguely like a torture chamber, but it's basically set up so that when we can take our rocket or spacecraft and put the section here with all the antennas and radios, because there's like a dozen radios on the vehicle, various, or either transmitters or receivers of various kinds, and we're going to make sure they don't interfere with one another and that they've got good. We can sort of verify that the signal that's going out is going to be well received by the ground, and that's what we use this chamber for. It's really great.